by Meenakshi Arya Madam from SRM University. And now we are going to have more detailed discussion on CNN and implementation of CNN using transfer learning for image classification. So to conduct this technical session, we have with us Mr. Yogendra Singh. Yogendra Singh sir is a co-founder and director of Fox Technology and Fox Coding School. He has several years of experience with leading companies like Qualcomm, Mango, and Z Drive. While working with these companies, he has played a strategic and key role in deploying hundreds of applications successfully. Sir was part of the team that developed a framework for low and mid-tier mobile devices that enable developers to quickly create customized mobile application and user experiences. The product was sold to Qualcomm Inc., which was the world's largest semiconductor company. Fox Technology is consulting startup and companies outside India in the domain of analytics, machine learning, and deep learning. I welcome you, sir, in this session.
Thank you, Deepak sir. Please confirm if you can hear me.
Yes, sir. Over to you, sir. The screen is visible now.
Okay, thank you, sir. Thank you, Deepak sir, for a nice introduction. So, a very good morning to all of the participants. This is Yogendra, and as Deepak sir have already introduced my profile to you. So now I think we can directly start with the agenda for today. So I'll off my video. That's not required, but screen sharing would be there with you. So just hold on. Let me now stop it first. Now I would request everybody, all the participants, that in case if you have any query or any question related to the session, you can post that query on the chat window that you have in the Google Meet. And I think it is visible to everyone. Otherwise, I will read it loud so that every participant can also hear what was the question, and I'll try to answer that as well. So welcome and good morning again, all of the participants. As Deepak sir, already explained that the topic of the session is implementation of transfer learning for image classification. And when you look at the topic, basically it has got two components, right? So one component that you can see is that we should be focused on understanding this, that what the transfer learning is. And obviously, the other part or the other component of this would be image classification, right? So, if I just drive what we need to do to understand this entire or whole topic, so obviously we need to have a image classification first, that we should have a knowledge around that, and then finally we should also have a learning or understanding around a transfer learning, right? That is there. Okay. Now coming to the part of image classification. So let me switch to the new slide. Okay. See, when we say image classification, so as per machine learning definition or a deep learning definition, the classification means giving a prediction, right? And in that prediction, you have to predict some category or a class. The best example as of now, or the simplest example I can take as of now, that you have an input image, right? And then your model has to predict whether in the input image it's a dog or it's a cat, right? The most famous example used in the literature. So then it becomes a classification problem, right? Or if you talk about the classification of, let's say, fruits, so whether it's an apple or whether it's an orange or whether it's a banana or whether it's some other fruit, again, this is also a classification. Maybe you have deployed your model with a camera, and that camera is giving you a feed of the images on, images of the vehicles that are, that are on the road. So maybe using that model, you can give a prediction whether the vehicle was a car or a bike or a truck or something else. Then again, it is also an image classification, right? And when you talk about image classification, right? When you talk about image classification, obviously in this domain, deep learning is being used, right? So you are using deep learning, and within the domain of deep learning, the most popular architecture that can be used for image classification is obviously CNN. And as Deepak sir told, that already we had sessions around understanding the concept of CNN, and some practical implementations or practical uses as well. So I will not go into much deeper focus on that. But CNN is what? A CNN is kind of a feature extraction mechanism, right? So what is CNN? The CNN is a feature extraction mechanism that is there. Okay, what we are trying to do here, that if you have an image, right? If you have an image, you apply CNN on that, and after applying the CNN, the data you get is basically a feature matrix, right? The data is feature matrix. This data has the features extracted from the image. So it's a kind of whether this is image, and then you apply CNN on it, and then it gets the features extracted from that image. This is basically a CNN utility. So what is the purpose of CNN? The CNN simple purpose is to extract the features from our input image, or extract the features from your training data, right? That is the purpose. Now, if you talk about, let's say you talk about that how the feature extraction takes place, okay? How the feature extraction takes place, there are 4 steps to do that. And this is now known to everybody who have attended the earlier sessions, right? The feature extraction in the CNN is, done through 4 steps, if you remember. The first step that happens while applying the CNN on a given image or on a given image data set, the first step that happens is convolution, right? The first step that happens is convolution. And when you are saying that convolution, it's a kind of a mathematical, operation. Everybody knows about it, right? It's a kind of a mathematical operations. And uh, after the convolution, right? After the convolution, you apply a transfer function or activation function that is called as ReLU, right? So whatever the output you get after the convolution process, and generally in the convolution process, you guys know that you have some input image, and now the convolution takes with a filter, right? And generally that filter is of 3 by 3 or so it's a 3 by 3 filter or 5 by 5 filter or 7 by 7 filter, and basically this filter gets convoluted with your input image, and then you get output, right? And sometimes what happens, sometimes during that process, some of your output pixels may be in negative range, right? Some of your output pixels may be in the negative range, and to handle that part, that you need to handle the negative pixels. So what you do during the ReLU, you just put your negative pixel values to 0. That's the simple utility of a ReLU, right? Everybody knows that how the ReLU works. If you have a input less than 0, that is, you have a negative input, then the output would be always 0. Otherwise, your output is always same as input. So that's a simple utility of ReLU. In the third process of CNN, the third process is known as max pooling, right? That step is known as max pooling, and basically max pooling is kind of a main activity regarding the feature extraction. This max pooling activity actually retains the prominent features from your data. So it retains the prominent features, right? That means the data related to important features in the image or pixels related to important features in the image are retained, and rest of other things are left. That means in the max pooling, you are doing two stuff. The one thing that you are retaining only the prominent features and others are left, and that's why this also becomes kind of a dimension reduction technique as well, right? Why the dimension reduction will happen? Because now you know that in case of a feature extraction, let's say you have an image with the a 2 by 2. So what happens generally? In this case, we will only pick the pixel value which is maximum. So let's say this is 10, this is 20, this is 13, and this is 5. So what you will do in the output, you will only consider the maximum value pixel. So this one is left, this one is left, this one is left, right? So that means you are converting your 4 pixels to just 1 pixel, right? So here you have 4 pixels and here you have just 1 pixel. That means it is a kind of a dimension reduction technique as well, right? So you are retaining the prominent feature. That is one, a thing, but at the same time there is a reduction in the size of your data, your input image, right? And this is called as max pooling, right? And in the fourth step, right, when you talk about what happens after the max pooling, in the fourth step there is a step called flattening, right? And what happens in the flattening? Basically, what feature matrix you have got out of the max pooling process, this data that you get after applying the max pooling technique, that is known as a feature matrix, right? That is known as feature matrix because it has all the prominent or important features that are required for your processing, right, or to get the right prediction or to get the right outcome. So what you do in the flattening? In the flattening, basically you reshape your two-dimensional feature matrix into one dimension. That's it, right? That is the only way. So flattening or raveling, sometimes people call it as a raveling as well, right? So it is just a reshaping activity, right? So you are converting your two-dimensional data into one-dimensional data, and after this part, right? After this part, so let's take another, a slide now. So you have convolution, you have ReLU, you have a max pool, and you have finally flattening of the data, right? So flattening was simply a process of converting two-dimensional data to one-dimensional data, right? And now what will happen? Let's say your one-dimensional data is this. This is your one-dimensional data now, okay? So, and now what will happen once your 2D data has been converted into a one-dimensional data? Now this, one-dimensional data here you can see these are the kind of prominent features, right? So 1 pixel is this, 1 pixel is this, one more. So how many pixels you have in one-dimensional data, you push this data, right? You push this data to a ANN model. So you will push this data to a input layer, and then some hidden layer may be applied, right? Some hidden layer may be applied, and then finally you get to the output layer. That will give you the prediction, right? That will give you the prediction. And basically this entire model here you see is ANN, right? This is only ANN. So up to here, this one is your CNN process. You have extracted the feature, and finally that feature has been converted to one-dimensional data, and then one-dimensional data is being pushed or fed to your neural network, which is artificial neural network, ANN. And because whatever you do, right, CNN is not giving the classification. Who is doing the classification for you? ANN is doing the classification for you, because ANN is a kind of a model that can be used for regression as well, or it can be used for classification as well. So ultimate decision is taken up by the ANN only. CNN is doing just a feature extraction for you. So this is how the entire process looks like when you look at the image classification kind of concept in the deep learning. So if I just give you a kind of a black box around that, so this is your, so whenever people say CNN, so basically CNN has two components, right? So CNN, which is like convolution and ReLU and then max pooling and then flattening, and whatever you get out of this CNN block, this goes to your ANN block, right? And finally, it gives you the prediction. So this was your input data, and here you get the predictions, right? So here you get the classification that in the image, whether it's a cat or it's a dog, right? So this is how this entire process takes place. So now I would request all the faculty members to give me a feedback that is that clear? Is this concept? So I'm sure that already you have attended so many sessions around that, so that should be clear. But I want to make sure that everybody is on the same page now. So please give me a feedback on the chat if you can, uh, that this is okay with you. Okay, so Jitendra Jaswal is saying yes. Thank you, Jitendra ji. Raghavendra God, Ajanta Devi, Archana Nimal. Okay, yeah, thank you, very good. Fareen Saista. Okay, a lot of people are there. Thank you for that. Yeah. So after after this part, let's move to a little practical side of it, right? Let's move to a little practical side of it. Okay, that how you can use a CNN for a feature extraction, and how come you can give a prediction for a particular input image. Okay, for that, now we need to understand couple of implementation concepts. So now I'm moving to an implementation of image classification, right? So for the implementation, because as of now we were just talking kind of a academic view of CNN and the ANN, right? Now I think we should go to applied side of this, right? So we should talk about the applied side of CNN, that how CNN actually can be used for some problem solving. That is also equally important now. So let's talk about that, what tool and technology we can use for applied side of the CNN, or the concept that we know now that CNN can be used for image classification, feature extraction, etc., etc. So for doing that, as of now, industry is using Python as the primary language for anything related to machine learning, anything related to deep learning, anything related to AI. This has become the kind of a de facto standard language for performing the research work or implementation or problem solving in the industry. That doesn't mean that Python is the only language to carry out this, but as of now, I'm talking about the most popular language as of now. Even in the Stack Overflow survey from 2019, a worldwide community of the developers has given a vote to Python as the most popular programming language as of now in the industry. Okay, so we'll use Python for that. People are using R and other tools as well. So R is also there, SAS is also there, right? And some other tools are also available. But you want to do a customization, obviously, that can be your list. You can go with. After understanding that which programming language you should use for the implementation purpose or the applied side of the research, right? Now we should come to know that Python, why the Python has become so popular language. So Python's power is in its libraries, right? So Python has lot of libraries or frameworks which can be directly used by the developers for their implementation purpose. right? And if you want to use, Python and the other related libraries, so let's say you start with the data analytics kind of stuff, right? That you want to perform data analytics, you have some data and you want to find out some insights out of the data. Along with the Python, you should know about three libraries, that is pandas, that is numpy, and that is matplotlib. Okay, so pandas is kind of a library which can be used to read your data, load your data, doing some data cleaning, or kind of a data preparation activity for your model, right? Because what happens in most of the cases when you talk about a research, a problem, or when you are into academic setup, most of the people are doing what, that whenever they talk about modeling or creating a machine learning model, they already deal with a clean data, right? Already data is in a CSV format, right? And that is cleanest form of the data available. At most, you can handle the missing value concept. That's it, right? Not beyond that. But in reality, data is not like that. So even before you go for a modeling, you have to do a lot of data cleaning activities, and that is known as data, processing activities. Then only you can feed that data to a model. So that cleanup takes a good amount of time, around 70% to 80% of the entire project implementation goes into the data preparation only, right? So you need to have a good understanding around pandas if you want to do that. And if you want to perform some mathematical operations, you should be knowing about NumPy. And if you want to do some visualization, you should be knowing about Matplotlib. If you are not very excited about the coding and writing your customized code, you can use some other tools as well. Let's say Power BI is the one tool that can be used for analytics purpose. It doesn't require any coding. It's just a kind of a drag and drop tool from Microsoft, very popular yet. And the other tool that can be used for is the Tableau. So I was talking about the data analytics, right? When you go for the machine learning side, there is a library called sklearn, right? There is a library called sklearn. In the code, people are referring it as sklearn, but in the documentation or in the literature, this is known as scikit-learn, right? And when you talk about the deep learning, you have libraries called Keras is there from Google, TensorFlow is there from Google, PyTorch is there from Facebook, right? MXNet is there from Amazon. So a lot of other libraries are also there, but these libraries are primarily for deep learning purpose, right? These libraries are primarily for deep learning. And just to distinguish that where you should go for a machine learning kind of approach, or you should go for a deep learning kind of approach, if you have some large amount of a data, the data which is in a kind of image format or a video format or a text format or an audio format, that kind of a data is best for deep learning projects, because all the deep learning algorithms are very data hungry, right? All of the deep learning algorithms are very data hungry. So if you don't give the right amount of data, or your data size is not adequate, they will not perform well. In that case, your machine learning algorithms will perform well. So because they can give you the good results even if your data set is not large or big enough, right? Still they can give the good results. But the deep learning particularly neural network is basically a very data hungry architecture. You need to have a lot of data, then only they will behave on the expected way actually. So that's about tool and technology. So we are going to use Python. Okay, we may need pandas as well, and we'll use this Keras. Okay, behind the scene, Keras is using TensorFlow only. So Keras as an independent library has no capability to deal with the deep learning implementations. Behind the scene, it is using TensorFlow. So basically, Keras is kind of a wrapper. So it is TensorFlow, or उस TensorFlow के ऊपर we have written the Keras. So this is how. So Keras works as a wrapper. The reason of bringing Keras on the top of TensorFlow is very simple, because when you use Keras, the coding of the Keras is very similar the way you code in scikit-learn. So if you know how to code the scikit-learn, library methods and how to call them and how to use it, you have exact similarity in the Keras as well. You can use the similar way. So that's why people sometimes prefer Keras as well. But if you need more performance, if you need more customization, you need more control over your neural network, maybe you can directly go to TensorFlow as well. Okay, so that was about tool and technology we use for deep learning projects. Now, coming to a problem, that what problem we are taking to understand the CNN kind of work on the applied side or on the practical side. So I'll take one example from our experience only. So we had a client. Okay, so there was a gentleman, right? So we had a client. So this is a client. Okay, and now a client has a problem. Obviously, whenever he has a problem, then only he will approach you, right? Okay, so he has a problem. Now what the problem he has, let's talk about that, right? So he wants to make a application, he wants to build a application, wants, right, to build a app. Okay, what that app will do, let's first understand the functionality of that. That application should be very simple, that this is your application. So as of now, it's a kind of a black box for you. So the client wants that whenever I give some input image right here, it should give me a classification that who is in the image, right? Who is in the image that is there. Okay, who is in the image. And now we asked a question to the client that do you have this data, right? So that we can train the model, because now we understand this application have to be some deep learning model, right? Then only it can give us a prediction. So client said that I want you to recognize the images of Pokemon. Okay, I want you to recognize the images of a Pokemon. So Pokemon is a very famous a cartoon character. If you remember your childhood days, you must have seen your kids loving this character very much. So this Pokemon is a famous character, and it comes in different different avatars, right? It has different avatars. So Pokemon is a general name, but specific names are something else. Okay, so the client says that I have a collection of Pokemon images, and you need to build an application. So whenever I give some Pokemon image to that application, it should recognize the name. Okay, so we then the client says that as of now, I'm interested that you should recognize whether the Pokemon is Pikachu. So it's a one avatar of the Pokemon, right? Or whether it's a Bulbasaur, right? Or whether it's a Charmander, right? So these are the only three, types of Pokemon you need to recognize. Okay, then we got the problem statement. So extract of the problem was like that, that client has some images and now he wants to build an application, and that application should successfully recognize the Pokemon images and categorize them into three different classes, whether it's a Pikachu image, whether it's a Bulbasaur, whether it's a Charmander, right? So that was the problem statement for us. And now to deploy a deep learning model, you need a data, right? You need to have a data set for that. So we asked the next question to client, that do you have the data? The client says, yes, I have a couple of images. So I have, let's say, 8 to 10 images from each category, right? So I have 8 to 10 images of Pikachu, I have 8 to 10 images of Bulbasaur, and I have 8 to 10 images of the Charmander. So all the faculty members now tell me that is it a good data set? Is it enough, right? A data set, is the volume enough that we can train our deep learning model to recognize the images? Raghavendra God says no. Yes, Raghavendraji, you are right. It's not enough data. Data is not enough, right? Because merely having 8 to 10 images from each category, that sums up around like 30 images, right? 25, 30 images. That will not serve the purpose, because I've already told you, right? All the neural network architectures are very data hungry, right? You need to give a lot of data, then only they will behave in the right way. So in that case, we are now into a different problem, right? Now we are into a different problem. And what is the different problem now? That client is there, client has shared a problem statement, client has shared whatever the data he has, right, related to that problem. And now when we say a next question, or when we have a next query to the client, that do you have more images? Client says, no, I don't have any more images. So now as a company, it is onus on us that we should find out a more collection of the images, right, which belong to Pikachu or Bulbasaur or Charmander. You need more images. So now, as a first step to solve this problem is that you need to perform a data collection activity, right? The activity that you need to perform is the data collection activity. So that is the first activity. That think, don't think about the deep learning model yet. First of all, you need to handle the data collection activity. So from where we can get the data, from where we can get the images, right? So at least we have 100 or 200 kind of images for each category, so that that the count goes around 500 at least, right? So then we thought of moving to a god of almost everything, that is Google, right? So now Google, you can go on the Google and browse for different images belonging to Pikachu, Bulbasaur, and Charmander, and then you can download them, right? But that's a very manual process, right? Someone from the team has to sit on the Google and search the images, and then download them, and then right, complete that entire exercise, and that may take a couple of days. And let's say if you are hiring an intern who does not know what to do, he or she may take entire week for doing that, right? So what we thought, that can we automate the process of data collection activity, right? Can we automate the process of data collection activity? And to automate that activity, we wrote a code in Python, right? So we wrote a code in Python, and what exactly that Python code was doing, that Python code was automatically downloading the images and saving them in a folder. So how exactly the entire process was going on, I'm not going into the other details, but that Python script was working as a client actually, right? That Python script was working as a client, right? And basically it was making a request to another search engine. Microsoft also has a search engine called Bing, right? So that search engine was there. So this client was making a STTP request, right? So it was making a STTP request, and Microsoft Bing search engine has a API. So on the documentation or doing the Google, we came to know that Microsoft Bing search engine has the API to collect or to download the images. So we called that API, right? So it required some secret key and some other authorization code as well, that you can get from the developer site there. And when we successfully, wrote that script, so what was happening? We were making a request that I need Pikachu images, I need Bulbasaur images. So in the response, we were getting an image, right? So this way, we were able to successfully collect a data set where around 150 to 200 images from Pikachu, 150 to 200 images from Bulbasaur, and 150 to 200 images for Charmander. So that was the first process of a data collection activity we took, right? And this way that part was done, and that was completely automated. It was a no manual activity. Okay, so that part was done. Now question comes up, right? Now question comes up that now how use this data to train your model. So first you need to have a model now, right? You need to have a model, and you need to have a CNN model that can work on this data, that can read this data and train the model to give the predictions. Okay, so let's talk about that now. So here you will see there is a collab, window that you can see. I have already opened up, right? And when you work in the collab, everybody knows that the file extension, right, is IPYNV, which is Interactive Python Notebooks, right? Interactive Python Notebooks, and here is that code. Here is that code. Okay, so first of all, yeah, Pratik, please, Shrestha Pratik, please tell me.
Yes, sir. So just one thing is that let's say that we are searching for something in Google, Bing, or anything, right? So in this case, let's say a Pokemon itself. While we search for a certain Pokemon, like you said, like extracting the images, it's not necessary that the search will give only that, right? There may be image that has different categories or an image that's completely different from what we are trying to search. So won't
Right.
that create any,
Yeah.
let's say,
So,
mistakes or something?
Shrestha, it's a very good question and a very good concern as well from your side. So, what happens, Shrestha, when you do automation, it is very well possible that some of the images may not, really belonging to a certain category which you are looking for, right? Let's say you are, going for a Bulbasaur images, but that actual images may not be a Bulbasaur images. So, there are two problems here, but that is very limited, right? So, rather than having completely manual activity of downloading every image from the Google, right, and then only in the last when your entire script has run and it has downloaded all the images, right, so browsing through those images and just manually checking and making sure that every image is fine, right, so hardly out of 40-50 images you'll find one image which is really not belonging to that category, so that you can filter out easily. Other problem that we have seen, sometimes the images that you have downloaded, they are corrupt images, Shrestha, right, and that corrupt image is basically the image that you cannot load in the that image browser, or your system cannot read those images, that because the data somehow has corrupted. So sometimes we got to know those corrupted images at the time of training the model only, that whenever model during the training process got stopped, and then we came to know that how come it had stopped. So there was a issue with the reading the data, the image was not in the right format, or it was a corrupted image. So that happens, but that compared to the entire manual process, that is just 5 or 10% part of that. Shrestha, is that clear to you? Did I answer your question?
Yes, so just another thing, like, won't it affect at all or like the whole data set? Will it affect those kind of
Okay.
minor, let's say, mistakes?
Say again, I didn't get you,
I mean,
Shrestha.
like, while we train the data set, right?
Mhm.
So because of that fault images, will it affect the whole process?
Somehow, but very unlikely that it will deviate, more than 1% or 2% from the as expected behavior. That is very unlikely, because what will happen sometimes, Shrestha, let's say you didn't focus on that part, that some of the images may be in the wrong category, right? Although they belong to Pokemon, but they are in the wrong category. So in that case, your model may not perform as usual, and then you go back to see that where the problem is, right? Sometimes that happens, Shrestha, and in that case you will come to find out where the issue is, right? So sometimes that you may have to go for a reverse engineering kind of effect as well. So because your model is not working, everything seems to be fine, then you think that can we have some issue in the data set as well, and then you find out that yes, your data has some issues. So that is a very normal process of development, right?
Okay, so got it.
Yeah. Okay. Good question, Shrestha. Thank you. So, I was talking about that now. We are going to we are done with the data collection activity, and some questions were raised by Shrestha Pratik, so we answered those questions. And now we are moving, right? Now we are moving to creating a CNN model that can extract the features from that data. So now we are building a CNN. Okay, so here you can see, to build a CNN, you have to import a couple of things. And now from the previous sessions that we are using a keras, and then here you can see we are importing a sequential model, the convolution, the max pooling, the flatten, the dense. So dense is for ANN purpose, and rest of the four, they are related to CNN. So you create a sequential model first, which is a empty, You have no layers inside that, right? And then you keep on adding some convolution, then you keep on adding some max pooling, and then keep on adding the flatten. Okay, so that was the import you have to do. So here you can see how we are creating, how we are actually, uh, doing a CNN model building exercise. So here you can see we are first creating the object of a sequential class, and once that object is created, once that a container is created, once that empty container is created, more precisely, you keep on adding the required layers, right? So first of all, you are adding a convolution layer where you are applying 32 filters. Every filter is of a 3 by 3 size. This count can change. It's not fixed, right? It is not fixed. It depends on you how many filters you want to apply on a particular data set. So we applied 32 filters, and every filter is of a 3 by 3, right? And here, while adding this layer, convolution 2D, that is for convolution purpose, the first step that you take in the CNN, here you are specifying the input size of the data. So what you are telling here with this statement, it's a key value pair of kind of combination. Input shape is equal to 64 by 64 by 3. So basically what exactly you are telling your CNN model that I will feed all of the images whose size is this. That means all of my images will be of this size, 64 by 64 by 3. And there is a problem for us because the images that we have downloaded, right, they may be of a different size, right? We never gave a focus that what is the size of my image. We just downloaded them, right, using API call, and we stored them. And it is very natural that every image can be of a different size, right? So how come we make sure that while giving the data for training to CNN model, how we make sure that every image is of a 64 by 64 by 3. So it's a kind of a resizing images at the time of training the model, right? So this is the one activity we have to take care of, because as of now we are just committing, we are making a commitment to our model that I will give you all the images of this format only, 64 by 64 by 3. So this is like, height, width, and depth, right? So this is the one problem we have to deal with, right, when we go for model, training of the model. And then immediately you're also saying that I will apply activation function rail. Can you see? I will apply activation function rail on that. So that is there. So you have added the first convolution layer here, where you have specified the number of filters, the filter size, the input image size, right, which is a problem we have to deal with, and then you the activation function. And the next step, what you're doing a max pooling. So you do a max pooling where your pool window size is 2 by 2. Default it is 2 by 2 only, but you can change it as well. And then you are adding a second convolution layer. So that may happen in any CNN, right? You can have a multiple occurrences of convolution max pooling, convolution max pooling, convolution max pooling, so kind of that, right? So this is again a convolution, and here as well you are specifying the number of filters, the filter size, the activation, and finally you are doing a max pooling. So you have done the convolution max pooling twice in a row, and then finally you are flattening your data. So this is your CNN, right? And after that, whatever you see in the code, that will belong to ANN, right? So your flattening has done. You have converted your feature matrix that was extracted after the max pooling process. So you are flattening your data, and now this flattened data will go to your ANN, and that's why you are now adding dense layers. So because dense layer is used in ANN building, right? And here you have to specify that how many hidden nodes you have, what the activation function. And here you can see this is our last layer, where now you know that how we decide the number of nodes in the last layer. The number of nodes in the last layer is always decided by the problem statement, right? You have to see whether it's a classification problem or whether it's a regression problem. Obviously, it's a classification problem, so accordingly you have to go for the activation function. If it is a classification problem, you have to see whether it's a binary classification or it's a multi-class classification. If it's a binary classification, that means you can use sigmoid as the activation function. If it's a multi-class classification, you have to go for softmax activation function, right? So this is how you can deal with. And then the number of units are decided by the number of categories, right? So if it is a binary classification, you can handle the problem using just one node. One unit is enough, right? So unit equal to 1, activation is equal to a sigmoid. If it is a binary classification, that means you have just 2 classes. But in our case, all of you know we have 3 classes. Pokemon data set में 3 classes हैं, right? We have one category as Pikachu, we have another category as Charmander, we have the third category as Bulbasaur. So there are 3 categories, and that's why you need 3 units, right? 3 number of nodes you need in the last layer, and the activation has to be obviously softmax. So this is how you create a CNN followed by ANN. So that becomes a complete package of your CNN, right? So this is how, and finally you have to compile it. So while compiling, you have to specify a lot of things, that what would be the gradient descent algorithm that would be using. So optimizer is equal to Adam. So Adam is a optimizer. Adam is a algorithm that will perform. Adam is an optimizer that will perform a gradient descent approach, and also handle the back propagation. That during the back propagation, how to update the weights and everything, right? So it is all handled by Adam. I'm sure people will not know as they do it for the first time. That's why the Keras has a very good documentation, keras.io. Right, so keras.io is there for everything. So they have a code as well and everything. So so here you can see a lot of this is there, and here you can see transfer learning and fine tuning the agenda for today's session as well. So a lot of everything is there, and here only you can find out that what are the different optimizers which are possible in this, right? And here you can see the sequential model, the sequential class. There is a one more model that you can create in the Keras functional API that we hardly use. Jyatar, in most of the cases, what I have seen, people are using the sequential model only to create a model and do the required stuff. But functional API is also there. That is used in rare cases, but a very powerful mechanism yet. So if I say what is the optimizer, so let's see optimizer. So here you can see optimizers, and when I go to this link, it tells you what are the different optimizers available and how come they are different from each other. So here you can see SGD, RMS prop. So RMS prop is mostly used for regression techniques, Adam, ADA delta, ADA grad, ADA max, NADAM, federal. So a lot of optimizers are available there, and you can use one of them. But obviously, the most popular one is Adam. So people go for that. But you can change that. Okay, and generally the difference in the optimizer comes that what learning rate they are taking, how they are optimizing the weights and everything, or what cost function they are applying for. So that's how every optimizer is different. So this is how you finally compile your model. So this is how exactly your CNN model is ready. So please give me a feedback from your side that are you happy with the CNN model that we have created? It's a model created. Training is not done yet. I will come to that part a little later, right? But I have told you that how using a Keras you can create a model, and for that purpose we are using a sequential module. We are using convolution 2D, max pooling 2D, flatten, dense. So this is how we have created our CNN model. So please share your feedback, all the faculty members here. So this is how you create a CNN model for your problem statement. And now as a next step, we have to train the model, right? As a next step, what we have to do, we have to train a model, right? And now, first of all, what we have to do, we have to understand a concept that if we want to train the model, how our data should be organized, right? So what is my next point of discussion is that, okay, I'm done. I have created a convolution, model for me. So this is I have already created, if you remember. So in a pictorial representation. I have added a convolution which has 32 filters with a size 3 by 3. Then I have done a max pool, right? Again, I have added the 32 filters with a 3 by 3. Then I have done the max pool, right? Then I have done the flattening of the data. So flatten has happened. Then I have taken the hidden layer 128 nodes, and then finally I have taken 3 nodes, right? So this is your entire CNN model that you have created in your code. So this is your CNN model, right? CNN plus CNN to be precise. Okay. Now question that how to feed the data, right? The question is now how to feed the data. So now we have to think where our data is. We downloaded that data, right? Using an API, the data is available. But now how we can expose that data set to this model now? That is the question, right? And for that purpose we have to follow a certain organization kind of pattern, that we need to understand that how we can organize our data so that our model successfully reads that data and the training becomes successful. So first of all, the data that we downloaded using that API, I have put that entire data on my Google Drive. So here you can see this is my Google Drive, okay, and this is the dataset folder. And here in this dataset folder, I have put all of my images that I downloaded from that script using a API from Microsoft Bing. But there is a one particular thing that you need to take care of, that you need to organize your data in a certain fashion. And what is that certain fashion? That please have a look on the screen, that what I'm telling you. This is your root data folder. This is your root folder. And inside this root folder, you have created 2 subfolders that you can see. One is training underscore sat, and the other one is test underscore sat, right? And now if you go in the training underscore sat, so let's go inside this, right? You will find 3 subfolders. And now you should be very clear that why we have created 3 subfolders, because each one folder is corresponding to one category of the problem statement, right? In the Pokemon, we had to decide amongst 3 categories, right? That which image is Bulbasaur, which one is Charmander, and which one is Pikachu. And that's why, because in your problem statement, you have 3, categories corresponding to each category. We have created a folder. So name has to be this only. That means the folder name has to be exactly same as your category name, right? Otherwise, you will have issues in your training the model, right? This is the way the Keras, so we have to go. To a documentation. Then only we can understand that why we are doing this organization, right? But as of now, I'm just telling you that if you want to train your model successfully, this is the way to do. Right, so you created a root folder. Inside the root folder, you have created 2 folders, one for testing purpose, one for training purpose. And this we will keep our entire training data. But how to keep the entire training data? If we go inside, we'll find out that we have created 3 different folders, one belonging to, each one belonging to one category, right? So we have this. And now what we have done, in the Bulbasaur folder, we have put all the images that belong to Bulbasaur. So here, if I go, you will see that all of these images belong to Bulbasaur only. So here we see. And now you can see the name can be anything. It doesn't matter what name you give. It's, any name. So here you can see the just numbering is there, right? 0, 0, 0, then 1, then 2, then 3, 4, 5, and so on. So it's just a naming has nothing to do here, guys. The name of the image has nothing to do, because this is the data. And so image is basically a feature, right? Because in the deep learning, all in the computer vision, all of you know that image pixels are features, right? So we have the features. And what is the label of this feature set? The label of this is this folder name, right? So ये data है, right? This is the set of features, and what is the right category, and what is the right label? The label is the folder name. So the label will not be picked from this name, right? So label is picked while training. The label is this, right? So all of the images that are part of this folder, they all have the same label, which is Bulbasaur, right? So this is how you can see all of the images are from Bulbasaur. So here I can see Shrestha Pratik, that you can see now that while browsing, right, you can see all of the images are related to each other. If I see some outlier case here, Pratik, right? If I see some outlier case here, you will find, okay, this image, seems to be different. It's an outlier image, so maybe we can handle that. We can remove that image, right? So this is how you do that exercise. So here in the training set, similarly, you have the other folders as well. So this is how you organize your data whenever you want to build and train your CNN model. So can I get a confirmation that is the data organization clear to everybody? That how we have organized the data on our Google Drive? So Ajanta is saying yes. Sresh Chapati is also saying yes. Okay. Now you know that if this data is available on the Google Drive, right, you should have some mechanism so that you can access the data from your collab, right? So to access the data which is available on the Google Drive, you need to mount the Google Drive, and there is a direct command available, right? So this is the command that you can use to mount your a Google Drive, and that way you can now access your uh, that now you can access your data that is there. So this is done. So guys, what we are done, we are done with the problem statement, we are done with the data collection, we are done building a CNN model, we are done with the organization of the data. Okay, now let's move to the next step, right? Let's move to a next step. So that will I will talk it about now. Okay, so here everything seems to be very good. Okay, now what we have done, we have in our Google Drive, we have created a folder dataset. Inside the dataset folder, we have created 3 different folders. One is for Pikachu, one is for Bulbasaur, one is for Charmander, and inside every folder, right, inside every folder you have the different images now. So these are the images, right? These are images. So all the images belong to Pikachu. The similarly you have created, Bulbasaur, and so this is how. Okay, now we are moving into a next step. So now around 150 images we have in Pikachu. Similarly, 150, 160 images we have belonging to Bulbasaur, and similarly 150 to 200 images from Charmander. Okay, that is there. So these are the okay. But again, I'm restating my statement regarding the neural networks, that neural networks are very data hungry. So with that definition, still having just 150 images, 100 images, 150 images corresponding to every class is not a very good data size. It's not a very good data volume that you can consider as the good data volume to train your model and get the good results, right? So now we are into another a problem, that what to do if you have not the enough data, training data to train the model. So we are into another problem now, guys. We have done our problem statement. We have done, building our CNN. We are also done with the organization of the data. Now we are into another problem, that we have done everything correctly, but still we are not up to the mark in terms of data size. Our training volume is not big enough. What to do now? Is there any mechanism through which we can expand our training data set? Is there any mechanism through which we can expand our training data? As of now we are done, right? So what we can do as an additional exercise so that our training data set gets expanded. And guys, now I will let you know that there is a technique in deep learning or machine learning domain that can be used to expand your training data set. Okay, and that technique is known as data augmentation. So guys, now I'm talking about different technique that is called as data augmentation. If I clearly define what the data augmentation, so data augmentation is kind of a technique that can be used to artificially expand the size of the training data set by creating a modified versions of images in the data set. What I'm telling you. So this is let me, okay, I have one, some written, so मैंने कुछ text लिखा हुआ था that I can share with you. So this is how your data augmentation is. What is the augmentation? The augmentation is a technique that can be used to artificially expand the size of a training data set by creating a modified versions of the images in the data set. So the statement is very clear that if you have some set of images, you can create more images out of that, and these images would be a modified version of the original images only. So how we can create the additional images from the existing ones, that is the technique known as data augmentation. So how to do that? What is the process? That process is very simple. If you see, let's say, so now I'm explaining how the data augmentation can be used to increase your data volume. So this is the data augmentation. So here you have, let's say, image, right? So this is the one image. Now this is your original image, right? ये तो हमारे पास पहले से data set में है. So this is the original image in the data set, right? So this is the image you have. Now guys, what you are doing, you are creating them some modified version. So how the modification can be done? So maybe we flip this image, right? Flip, let's say, left to right. So you will get one image. Maybe you do one more operation, flip top down. Okay, that is also one case. Maybe you rotate this by 45 degree. Okay, in that case, that can happen, right? So somehow maybe you share this image, right? Maybe you do one thing, that you crop one part of the image, right? So we are not considering the entire image, I will just crop this part, right? So cropping can happen. So there are a lot of things that can happen. So these are the artificial ways, kind of, right? These are the ways you can generate some modified images. So this is the modified image 1, this is the modified image 2, this is the modified image 3, this is the modified image 4 and 5. So here you can see that out of one original image, now you have 5 additional images, right? And in all of the cases, whether it's a tilted image, whether it's a rotated image, whether it's a cropped image, whether it's a zoomed image, whether it's a zoomed in image, in all of the cases, your CNN model correctly, distinguishes the image, right? Correctly identify the image, right? It doesn't matter that it should only identify this image only. No, all of the related images which are just one kind of a modified version of the original image, in cases में भी तो उसको सही prediction देना पड़ेगा. And that's why these images can be used also for training purpose, right? So now, rather than having only one image, now you have 1 plus 5 images, right? So rather than having one image only, now you have 1 plus 5 images. And that means if you have 1 plus 5 images corresponding to each image, in total, let's say you have 500 images, what will happen? In that case, now, originally you had 500 images, but each image has been expanded or has been modified to create new images. So now you have 3000 images in reality. So this is how a data augmentation works, and this is how you increase the training data set. This is known as data augmentation. Is that clear? Right? So this is how. Thank you, Raghavendra ji. So this is how you can do a data augmentation, but how we'll do it in the code? To do this, exercise in the code, you have a class, right? You have a class in your Keras library, and that class is known as image data generator. So what we are telling, we are doing an image data generator class को हमने import किया है, we have imported it, and now we are creating a object. So we will create 2 objects, one for training data set and one for test data set. Okay, so one for training data set and one for a test data set. Here you can see that while creating the object of this class so that we can perform data augmentation on our training data, we have specified so many parameters, right? I have done said that you should rescale it, you should shear it, you should zoom it, you should do a horizontal flip, a lot of things. But I have not specified anything as such in the test data, because I need more data on the training side, right? I don't need extra data for testing purpose. Testing purpose, I have some couple of images already in my folder, so I don't need it. What is my problem? That I should be able to expand the data set for training purpose so that model becomes optimal, model becomes robust, right? And that's why we are doing so many operations to create modified versions of the images. So that's why you can see we are shearing, we are zooming, we are doing horizontal flip. You can add more here, right? So it's not the exhaustive list. You can add more. For that, you need to just go through the documentation, that what additional parameters you can take to create additional images as a data augmentation process. So this is how, guys, these are just generator, right? Abhi inko nahi pata hai data kahan se padna hai. They don't know from where to get the data. So they are just generators, and we have to apply these generators on the a right directory. हमें बताना पड़ेगा कि this is the data source where you have to work and generate the additional images, right? This is just a creation of the object. It will not work as of now. It will only work when you apply these generators on the image folders where our images are, right? So we have to tell that please go to this location. There you will find all the images. So can you see, guys, this is the location where we have put all of our images. So can you see in drive, then my drive, then data set, and then you have training set, right? Can you see this training set, right? So this is how. And while applying this generator, that please generate additional images for me, we are also telling a one more a step to be done here. We are telling that why jab tu apna kaam kare, please generate all of your images in this size only, because we have given a commitment to our CNN model that you will feed all of the images in 64 by 64 by 3 only, right? And that's why we are saying that now target size for each image has to be 64 by 64. If you commit 150 by 150 there, right, you will have to change that here as well. You will have to make sure that you write 150 by 150 here. So this is how. And now you are saying that do the processing in the batch size of 32. Don't take the entire data set in one go, because you will not be able to do it. We have a limited memory, we have limited RAM. So you will not be able to load all the 500 images in one go and do the data augmentation on all the images. No, it's not possible for you. My RAM size is not that. Primary memory is limited, right? So I'm just telling the batch size of 32. So at a time, it will only take 32 images and perform a data augmentation. And right, it's not storing all these temporary images created or generated. They are directly fed to the model. They directly go to the model for training. So it's a kind of an on-the-fly generation, right? It's a kind of a dynamic, a mechanism. In the real time, we are generating these images and feeding to the model. We will know where to store them. The data generation happens, that's feed it to the model. Data generation happens for the next batch, feed it to the model. Data generation happens for the next batch, feed it to the model, and that's it, right? So this is how you do a data augmentation, a very important process here, right? And finally, this part is done. Now you can go and train your model, right? So earlier we used to call a method called fit generator, but now this is not used anymore. It is deprecated now. Now we can directly call the fit method, right? And in the fit method, you just have to tell where your training set is. So this is your training set. Can you see? This is your training set. From where you are getting it? You are getting it from the image generator, and that image generator applied to this drive, right? And then you get the training set. So this is how you get a training set. And then you have to specify the number of epochs and everything, right? So a couple of things you have to specify, and finally your model training is done. And once your model training is done, you can use it for your prediction purpose. This is how a CNN has been applied for image classification. This is how a CNN has been applied for image classification. We created a model in Python using Keras library. So while creating that model, we got couple of issues. One issue that we solved was data collection issue. So we solved that using a API. The another issue was the data organization issue that we solved by putting the data in the Google Drive and organizing the data in the right fashion. And then the third step was how to handle the limitation on the data size. So we applied a data augmentation technique so that we could expand our data size. Okay, there is a word of caution here. There is a very that you need to clear that is it necessary that every time I should go for data augmentation? I think that question can be there. That is it necessary that you should go for a data augmentation? I think it's not always necessary. If you have the enough data set, right, then there is no need for the data augmentation. In most of the cases, what is my experience? My experience is that whenever your data set is complex in nature, right, whenever your data set is in a complex in the nature, you should always go for the data augmentation. If your data set is very simple, I'm not talking about other image data sets, I'm talking about the image data set only. Let's say you have the image data set where you have couple of images like this, is tarike ki images, right? So you have a couple of images like that, you have images like that, you have images like that, you have some images like that, right? In this case, your CNN extractor will only try to extract the edges, right? Extract the edges, because the image structure is like that, that using the edge extraction, it can identify that किस symbol का क्या मतलब है, right? In that case, it is a very simple exercise. You don't need a data augmentation. Data augmentation is not required in such cases where you have a simple kind of images. Images are not very complex. But when you have the images, let's say Pokemon, let's say cat and dog, right? So now you have there is a lot of variation. The complexity has increased. Above simple, up down arrow, left down type के arrows नहीं बचे, right? अब now you can have so many things, right? कुछ में कैसा दिखेगा, कुछ में कैसा दिखेगा. So that data set has become a complex now, and that is kind of a perfect data set for your data augmentation activity. So this is kind of a experience that I can share with you. Right here, it will not very much help you. You can do it. No one will stop you, right? But that will hardly add any value in your quality of a classification model, right? So this is how you have to take a note of it, that कहाँ पे use करना है और कहाँ पे use नहीं करना. So this is how we are done with a image classification for CNN. So now I have 15 minutes, so I will focus on the second component of this session, that is a transfer learning. Okay, so now I'm coming to that part, that what the transfer learning is, right? So let's focus on that part, and I will add that concept into the existing code only. जो अभी तक हमने code बनाया है, उसी में मैं उसको add कर दूंगा कि how you can do a transfer learning, given you have this much of code with you, right? So now I'm going to talk about the another concept that is known as a transfer learning. So let's talk about that as well, what the transfer learning is. So basically this TL or transfer learning, so I'm talking about transfer learning. Okay, so in transfer learning, what is the academic definition of the transfer learning, if you talk about that? So basically transfer learning is this, let's say I would say using knowledge of image classification while solving a problem, right? So you are solving some problem of image classification, and definitely you have developed some knowledge around that. Now using that knowledge in solving other problem, and that problem obviously has to be related, right, from the first problem. So what is transfer learning? So let's say you are solving one problem here. So this is problem 1, and this is the problem P2. And for example, you have already developed a model which can do a classification of, for example, car. It can classify, right? So whether it's a car or not, right? Or maybe you can say whether it's a hatchback, okay, whether it's a hatchback car or whether it's a sedan or whether it's a SUV, right? So this is the classification you have built to classify the car, right? कि कार हमारी हैचबैक है, छोटी वाली है, या वो लंबी वाली सेडान है, या फिर वो स्पोर्ट्स यूटिलिटी व्हीकल है, SUV. So this is the three classes you have to do, and obviously you can create a CNN model, right? So CNN model is there, and then you have a ANN model there, and then you have to this input images, and then you have the prediction here, right? So now here we have a problem, right? P2. We are going to solve a P2 problem where we have to let's say identify the truck type, right? Truck type. So ट्रक छोटा वाला है, बड़ा वाला है, वो लॉरी टाइप है, कैसा है, किस तरीके का, so that kind of so whether it's a, let's say, Magic, or it's a 407, or it's a that bigger one from Tata, right? Or from that Mahindra, kind of that, right? So that truck type you have to identify, right? So yeah, thank you, Vijayan, for that note. Okay, so now what I'm talking about a concept known as transfer learning. So how the transfer learning, that I'm talking about, that you use the knowledge that you have gained here while solving this problem, in using this knowledge or transferring this knowledge into the domain of problem P2, right? So how come you can use this knowledge to solve this problem? This is transfer learning, right? And how the transfer learning takes place, I will explain that part now. Okay, so see what exactly we are doing here. See, if you look at this problem, what you are doing, you're doing a CNN, and then you're doing a ANN, right? And from outside, if I look at this box from the outside, this is known as base, this CNN, right? The feature extractor is known as base, and this one is known as top, right? So as a CNN model, right, as a black box model, what I see from outside, this part is known as base of the model, and this part is known as top of the model. Okay, and now when you train your model to basically predict whether it's a hatchback, whether it's a sedan, or whether it's a SUV car, right? What happened? It optimized the weights, right? It optimized the weights of the filter, right? It optimized the weights here, it optimized the weights here, and after the training, all the optimization because of the backtracking was done, right? That back propagation helped in optimizing the weights, and once all the weights are optimized, the CNN will perform the feature extraction to a optimal capacity, right? So now the feature extraction is very good here, right? So what we are doing now as a transfer learning, what we will do, we will take this CNN model here, right? We will take this CNN model. So this CNN model is same which is used for solving the problem P1, right? But we will not pick this ANN. We are not going to pick this ANN. This ANN was particularly for this problem only, but CNN is a feature extractor to extract the features from a particular vehicle image, right? So vehicle image is here only, vehicle image is here only. So this CNN is perfect to extract the features of a vehicle. And now what we will do, we have transferred this CNN to here only. Now we will write our own ANN here, right? We will write our own ANN here. We are not picking this ANN. We are writing our own ANN here because the ANN structure may be different. So here you have in the outside, in the output layer, you have 3 nodes only, right? One node corresponding to hatchback, one node corresponding to sedan, one node corresponding to SUV. So the structure is different, but now you have 4 categories here. Can you see? So you need one node for 8, you need one node for 8, one node for 1, 8 for 1. So in the output layer, you will need 4 nodes, right? That means ANN has to be different, but you can use the same CNN, right? So this is how the basic principle of transfer learning is, right? You have taken the base part, but you have left the top part. You are adding your own top part. So customization as per your problem P2 is happening here, but in both of the cases, the CNN is working same. So this is exactly the case of C, transfer learning, and transferring the model is simply that you are using the same weights that are used here in this problem as well. Okay, now there are a lot of this kind of a case for P2. This CNN is known as a pre-trained model. In case in the context of P2 problem, this is known as pre-trained model. Why pre-trained in the P2? Because this model has been trained in the context of P1. So this model is already trained. For me, it is already trained. So I will call this as a pre-trained model, guys. I will call this as a pre-trained model. And whenever I'm giving my data set to train the model, what is the additional care I have to take care? Guys, the weights are already optimized. So I have to make sure that while training, it should not update the weight, should not update the weight. Otherwise, the whole purpose of taking that CNN from the P1 is lost, right? So you should not update the weights of CNN. Only ANN weights would be updated, right? So you should freeze. इसको कहते हैं, we call this as a freezing of the weights, right? The freezing of the weights is done. So whenever you are using any pre-trained model, you have to take additional care that you should never change the weights of the base. You should never change the base of the CNN model. Any pre-trained model you can use. You can use BGG16, right? You can use BGG19. You can use ResNet. You can use couple of other pre-trained models, right? The most popular ones are VG16 or VGG19. You should never update their weights while training that. Only the weight updation will take place in this ANN model, which is your own ANN, not this ANN, right? So this is how a transfer learning takes place. And if I go into the code, how things are working. So here you can see that I have, can you see? I have taken VGG16. Can you see? I have taken VGG16, and while taking the VGG16 is a pre-trained CNN model, I'm saying include top is equal to false. Why I'm saying this? Include top is equal to false because I don't need ANN. I told you right in that image explanation that we will not use this ANN. We will only use the base part, right? So I'm just picking the base part from it. So I have taken the convolution base, and I'm excluding the top part. I'm excluding the ANN part. And now what I will do, I will use this layer, this CNN layer for my purpose. So can you see? Now I have used a sequential class which is initially blank, and now rather than adding a convolution 2D, I'm using this convolution base here. Can you see? In the earlier model, if you remember, I was using a convolution 2D, then max pooling, then convolution 2D, then max pooling. Can you see? I was using this part, convolution 2D, max pooling 2D, convolution 2D, max pooling. Now this entire stuff has been replaced by the VGG16 model, and I have used the base part from VGG16, so that you can see now, right? So here you have seen it. And now whatever I get from this convolution base, I will flatten it, and now I will feed that data into my own ANN model so that you can see, right? And this is how you have created your model. One additional thing, I told you that you need to freeze the weights of your CNN that you have added, right? You don't need to update, otherwise your entire purpose of using the pre-trained learning pre-trained model is lost, right? So convolution base dot trainable is equal to false, right? And that way you only train the weights here. That way you update the weights here only in your ANN. The weights will not get updated here when you say false. So this is how you can create your own model using a pre-trained model, and now you can use it for solving your purpose. The other activities are same now. You have to create one more generator, you will apply these generators, and then finally fit that data, right? Compile kiya, fit kiya, and all done. So this is the same, right? The only change that was different from the previous model where we were not using any pre-trained model. Now we are using a pre-trained model. That is the only difference that you see here. And the one more change that you have to make is this. So this is how you go for a transfer learn. So I would request now everybody to give me a feedback that is that clear what we were trying to understand. We were trying to understand the image classification using transfer learning. So I have explained both of the concepts, and finally I was able to merge them, right? Finally I was able to merge them. And during the CNN implementation, we had some practical issues which keep on coming whenever you are doing some client project. So I shared a couple of those knowledges as well with you. So please share your feedback. Did you like the session, or any issues related to the session? What is your feedback? What change would you like to see in the future sessions in case I get an opportunity to meet? So Unnati Shah is saying very informative session, sir. Thank you. Fareen Saista was saying informative session, sir. Right. Vijay and Vinita is saying how effective is transfer learning if features are inputted from feature extraction method like shift and surf. So Vijay, the shift and surf was the earlier mechanisms before the arrival of deep learning and having good capabilities around memory and processing. So shift and surf algorithms were used before that, right? So where feature extraction was done using shift and surf, now it has been automated using CNN, convolution, ReLU, and maxpool. That is the only difference, right? And I'm not very much sure about the quality of the shift and surf, but as of now, the shift and surf algorithms has taken the backseat now, and probably mostly people are using deep learning CNN techniques only for feature extraction. Vijayan. Santosh Kumar saying it was wonderful, sir. Thank you, Santosh, sir. Vijayan, did I answer your question, Vinita? CNN, because convolution layer itself is deciding the features to be selected, because the convolution is deciding the features based on the label only, right? That kind of a data you are given while training, right? That is the only way to decide that how the features would be selected. If you change the training data or the way you want to behave it, you can have a change in your training data itself, right? Or you may change the classes. Then you can have some changes in the convolution filters. Or either Vinita, what you can do, there is a mechanism in Keras where you can get the features extracted from each layer, right? You don't need that you will get the output in the last layer only. You can get the intermediate results as so. So maybe you can analyze those and see is there any mechanism you can influence them. Vinita.
Yeah. So I extend my sincere thanks to Yogendra sir for conducting this wonderful session of transfer learning. Thank you very much, sir.
Thank you, Deepak sir. Thanks for the invitation.
Right,
Thank
sir.
you. I'm
So
taking
now,
leave now. Bye.
right, sir. Thank you very much, sir.
Yeah.
So now we are closing session 2 of day 2, and we were moving forward to advanced topic of convolution neural network, how to extract features from intermediate layers, and how to apply those features into machine learning. This has been demand from many participants of previous faculty development programs. So we are introducing this session today in the last at 2 o'clock. So I request all the participants to join back at 2 o'clock for the last session of day 4. It is on image extraction from intermediate layers for image classification using convolutional neural network. Thank you very much for your participation. Please join back at 2 o'clock after lunch break.